Okay, let's just dive right into this explainer and uncover the glowing, invisible source code that literally holds our entire physical reality together. We interact with the physical world all day, every day, but we rarely stop to think about the invisible tethers making it all possible. So today, we're exploring electrostatics. It is the absolute bedrock of physics that keeps you, me, and everything around us perfectly intact. I mean, before we even look at atoms or planets, we really have to ask, what governs the fundamental physics engine of our universe at the most basic level? Have you ever wondered why your hand doesn't just phase right through the table? What exactly is the force dictating how matter interacts when it's seemingly just sitting there? Well, it all comes down to a set of hard-coded rules operating totally beneath our daily perception. We're about to decode the universe, and here is our exact flight path. We'll hit the basic entities, the environment, the core algorithm, some incredible geometric hacks, and finally, the system limits. Let's get into it. Section 1. The basic entities, positive and negative charge. So Ben Franklin actually named these foundational assets. And honestly, he could have called them anything, like, I don't know, cherry and walnut. But assigning positive and negative algebraic signs to electric charge was an absolute masterstroke. And here's the thing you gotta remember. Charge isn't some invisible fluid you can pour. It is an inescapable intrinsic property that's permanently hard-coded into fundamental particles. It just comes automatically with those particles wherever they exist, and it dictates the absolute bedrock of their electromagnetic interactions. The golden rule of this whole system is just elegantly simple. Particles with the same sign violently push away from each other, while opposites are irresistibly drawn together. Now, do we know exactly why the universe mandates this specific binary? Not really, but we have mathematically mastered exactly how this attraction and repulsion behaves. And you actually experience this code glitching in real life, right? Like when you get a static shock from a doorknob. Just by walking across a carpet, you're transferring excess charge and upsetting your body's neutral balance. But honestly, my absolute favorite example of this is chewing a wintergreen lifesaver in the dark. If you adapt your eyes to the darkness and chomp down, you will literally see faint blue flashes in your mouth. What's happening is, breaking a sugar crystal fractures it unevenly. One piece hoards extra electrons, becoming negative, and leaves the other piece positive. Because those opposite charges attract so fiercely, the electrons actually jump across the gap in a tiny lightning storm, just to reunite. It is so cool. All right, moving to section 2, the environment, conductors, and insulators. So having charge is one thing, but how does it actually travel? We basically classify materials into two main environments. In a conductor, think copper or even the human body, conduction electrons are free to cruise down open highways. Their outermost electrons are super loosely held and they just wander about the solid lattice. But in insulators, like rubber, plastic, or chemically pure water, those electrons are stuck in permanent bumper-to-bumper traffic gridlock. The highest energy band containing electrons is totally full, so they simply have no place to go. And by deliberately combining these two environments, like using components such as resistors to choke the flow or semiconductors like silicon to direct it, we actively manipulate that traffic. This precise control over the electron highway in the gridlock is literally the foundation of computers, telecommunications, and basically the entire hardware setup of our modern digital world. Which brings us to section 3. The core algorithm, Coulomb's law. Okay, so we know how charges behave, but what is the mathematical engine actually driving it? Coulomb's law. It dictates that the electrostatic force depends entirely on the magnitude of the two charges involved, divided by the square of the distance between them. This formula beautifully calculates the pure strength of the force using absolute values, while the positive or negative signs tell us the physical direction of the push or pull. Now check out this number. At roughly 8.99 billion, the electrostatic constant, we call it K, acts as a universal multiplier in this algorithm. And it reveals just how terrifyingly strong the electric force actually is. If you look at the structure of Coulomb's law, side by side with Newton's law of gravitation, they look remarkably similar, right? Both are inverse square laws, but because of this massive constant, the electrical force completely overpowers gravity at the microscopic scale. It's not even a contest. And because this is an inverse square law, distance is basically the ultimate dial controlling the intensity of these electrical interactions. If you move two charges just twice as far apart, the force between them dims to exactly 1/4 of its original strength. Conversely, if you halve the distance, boom, the force becomes 4 times as strong. But what happens when you're dealing with a chaotic system of, say, millions of particles? The universe keeps track using the principle of superposition. It calculates the net force on a single particle by geometrically adding the vectors of every single push and pull in three-dimensional space. You absolutely cannot just tally up their raw scalar numbers. It's a giant geometric math problem. So how does the universe handle that without lagging? Section 4, Geometric Hacks, this shell theorems. Calculating individual vectors for trillions of electrons in a massive sphere would be incredibly messy, right? But the universe has this brilliant geometric shortcut. Step 1 tells us that if you're outside a uniform shell of charge, it mathematically behaves as if all its charge is concentrated at a single, holographic point right in the center. And even wilder is step 2. If you place a charged particle inside that uniform shell, the forces pulling from all directions perfectly cancel each other out, instantly creating a completely force-free safe zone. It's like a built-in cheat code. And finally, we arrive at Section 5, System Limits, Quantization and Conservation. Think of these as the strict anti-cheat mechanisms of reality. Back in Franklin's day, people assumed electric charge was a continuous fluid, kind of like water. But experiments show it's actually grainy. Electric charge is quantized. That means any detectable charge, we'll call it Q, only comes in exact discrete packets of an elementary charge E, multiplied by an integer n. So you can have a charge of 1e, or maybe negative 6e, but you can never, ever have a charge of 3.57e. The universe just says no. And here is that exact value, 1.602 times 10 to the negative 19th coulombs. This elementary charge, E, is the exact quantum value of a single electron or proton. It literally represents the absolute minimum resolution, the base pixel size, if you will, of the universe's electrical code. Now, this quantum of charge is unimaginably small. I mean, billions of them flow through a simple light bulb every single second, which is exactly why electricity feels perfectly continuous to us, even though it really isn't. Alongside that quantization is an absolute, unbreakable law, the conservation of charge. No matter what chaotic physical processes happen, whether you're rubbing a glass rod with silk or violently smashing particles together in a collider, the universe maintains a strict, perfect ledger. You can never create or destroy net charge. You can only transfer it from one body to another, which might upset the neutrality of each, but it perfectly maintains the total overall balance of the system. The universe fiercely protects this ledger. Even in extreme quantum events like pair production, this is where an electrically neutral gamma ray literally manifests physical matter straight out of energy, creating an electron and a positron right there in a bubble chamber. But the math, it holds up perfectly. It creates one particle with a minus E charge and one with a plus E charge. -1 plus +1 equals exactly 0. The net charge before was 0, and the net charge after remains exactly 0. The accounting is absolutely flawless. Which really brings us to our final thought for this explainer. We know exactly how this source code operates, right? We've mapped the highways, defined the algorithms, and tested the hard limits. But it leaves us staring at one of the grandest mysteries in all of physics. Why is charge perfectly quantized into these discrete packets of E in the first place? What does that mathematical precision actually tell us about the deep, unseen fabric of our reality? It's a massive question that continues to drive modern physics today. And hopefully it leaves you wanting to dig even deeper into the invisible rules that govern our world. Thanks for hanging out with me, and keep questioning the code.